When we talk about infrastructure as code on AWS, Java might not really be the first language that comes to mind. Most AWS CDK examples use either Python or maybe TypeScript. But Java brings powerful object oriented principles directly to cloud architecture using the AWS CDK, which makes it quite powerful. In this video, we are deploying a VPC from the ground up. We'll first start by looking at the cloud deployment diagram, and we'll then run CIDR math to carve out our network topology and translate that design into a Java project. We'll also break down the complete infrastructure as code lifecycle for Java CDK, which is bootstrapping the environment, then synthesizing our Java logic into raw CloudFormation templates, and finally deploying the stack to AWS. Let's look at the architecture. Let's now look at the cloud deployment diagram in which we will be deploying our architecture. So in the diagram, we have two availability zones and we have a public subnet in each availability zone, as well as a private subnet in each availability zone as well. And we also have an internet gateway. So since we are going to be using the lower level constructs, we will have to provision each of these components manually, and we don't really have the luxury of the higher level constructs kind of making some of these things for us under the hood. Like for example, the internet gateway, if you were to use the higher level construct, it automatically takes care of provisioning that for you. But here, since we are going with the lower level construct, we will have to provision that from scratch. So now we have this deployment diagram and we have the subnets and the availability zones. But then again, we have to really figure out how it is that we are going to determine the network blocks for the entire VPC and for the subnets as well. So let's jump into the CIDR math section and let's really see how it is that we can divide these blocks into these sections. Let's now get into the CIDR math and let's look at the earlier cloud deployment diagram, and let's just assume that the entire VPC needs 50,000 IP addresses. Public subnet A needs 5,000, public subnet B needs 5,000, private subnet A needs 10,000, and private subnet B needs 10,000 as well. So let's maybe start with the main block and let's work our way down into figuring out the exact CIDR prefix lengths for each of these subnets, and we'll also have a look at the actual usable IP ranges for each of these subnets. So let's first start with the main block. Coming to the main block, let's first try to figure out the CIDR prefix length. So we can do that by first using the usable host equation. So that comes to 2 to the power h, which is greater than or equal to the total number of IP addresses we want, which comes to 50,000. So h comes to 16. 2 to the power 16 gives you 65,000 some value. So that should be more than enough. So if I were, so h comes to 16. So now let's try to figure out the exact prefix length. So if I were to deduct 32 from this, so 32 minus 16, that gives me 16. So 16 is the prefix length for the main block. So I can now select the private network block which I would like to go with. So I will go with, say, the 10 dot network. So then that comes to 10.0.0.0/16, and that's the CIDR prefix length alongside the main block. So this is our main block. So let's now maybe do the first subnet. So let's get into that. The order in which we evaluate the subnet depends as well. So you have to actually go in descending order according to the rule given by VLSM. So we first start with the largest IP address and then we work our way down to the lowest one. So in this case, private subnet A and private subnet B both have 10,000 IPs. So we are first going to start with that and then we are going to move on to the 5,000 IP subnets. Because what happens is if you were to start with the smaller subnet first, you wouldn't really have any space for the larger ones later on. Alright, so let's do private subnet A. So now we have to adjust the usable host formula because AWS actually steals 5 IP addresses from us, which is 0, 0.1, 0.2, 0.3, as well as the broadcast IP. So considering that in mind, we have to change our usable host equation. So then it comes to 2 to the power h minus 5, which is greater than or equal to the number of IP addresses we need for private subnet A, which comes to 10,000. So if you were to do the math on this one using good old logarithms, so we get log 10,005. So h actually comes to 14. If you were to go with 13, it's a much lower value than 10,000, so we are not going to go with that. So now that we have h is equal to 14, the next thing which we can do is we can figure out the CIDR mask. So let me be a bit quick here. So CIDR comes to 32 minus 14, which gives us, I believe that gives us 18. Hope I'm right. Yeah. And then the next thing we are going to want to do here is we have to figure out the interesting octets as well so that we know where it is that the jumps actually lie. So what I'm going to do next is, so we have this slash 18. So when we consider 18, we have so 8 minus 2, that gives us 6. So now if we were to do 2 to the power 6, that gives us 64. So 64 means you have 64 jumps in the 1, 2, 3, third octet. 64 jumps in third octet. So which means that the next starting IP is going to be, let me write that down, so 10.0.64.0 is going to be the next starting IP. So if we were to now get the final IP, so you just have to reduce 1 from this, so then that gives us 10.0.63.255. And now if you were to get the, so this is the broadcast IP. If you were to now get the final IP, you would have to reduce 1 from that. So that gives us 10.0.63.254. So let me quickly label that for you so that you know what's going on here. So 10.0.63.254 comes as our final IP. So let's now figure out what our starting IP is going to be, and we can evaluate that simply because this subnet A starts with 10.0.0.0, and if you remember what I said earlier, that AWS steals 5 of our IP addresses. So considering that, we can evaluate the usable range, and that is our usable range, and this is the prefix length, or rather the block for this particular subnet A. So I'll do the rest of the calculations for the other subnets and I'll have it on here in a while. Alright, so these are the subnets and their CIDR as well as the AWS usable range. So having mapped out all of these subnets, we are now ready to go into our IDE and finally program this into a VPC. Of course, we will be using the lower level construct, which means that we have to wire everything together manually. We will not be getting the advantage of the higher level construct. So without further ado, let's jump into the implementation. Let's now start the implementation for the VPC. So let's start by first creating the project and let's then work our way into it. So the first thing which we are going to do is we are going to create a folder called CDK. So let me quickly make a directory mkdir CDK. Okay, now if I were to, alright, and now we can initialize the CDK for Java. So we can do that using CDK init app language Java. In some cases you might have to give it some time. So let's have a look around at what has been created. So if I were to go into the SRC over here, we have a CDK app, we have some tests as well, CDK app, CDK stack. So of course, to make this an actual Java project, we'll have to make the POM Excel, we'll have to add it as a Maven project, and yes. So CDK app is basically like your starting point, and you are able to create stacks and wire all of it into this CDK app class here. If you're using the CLI and perhaps you want to use the same credentials, perhaps you're working with a different profile or such, you can uncomment the first few lines of code and it will fetch the default account and the default region. So let's create the VPC stack. So in order to do that, I can create a new stack. Let's call it VPC stack, and I can bring over some boilerplate code. So you actually have this boilerplate which has to be always included, so I'll make sure to include it here. So let's now wire the VPC stack class into our main class. So before we do that, we'll first create an object of stack props. So stack props is equal to stack props dot builder, and oops, env, taking that environment variable, and then we build it. So stack props is actually really easy because it helps you pass in the environment detail configurations into your stacks. So let me now create the object of the stack. So we can do VPC stack, new VPC stack, and we have to pass in certain arguments. So first thing we pass in app, then we pass in a name. So I call this VPC stack, and then we pass in stack props. So that's pretty much what the wiring was all about. So let's go ahead and let's now provision the VPC. Alright, let's finally build the VPC. So the first thing we are going to want to do is, of course, to create the VPC object. So we can do VPC, import it, of course. Let's call it something like demo VPC. So then we have to bring the thing in. So VPC dot builder dot create, give the scope. Then we can give a name. So again, demo VPC. Alright, so now remember the main CIDR block that we just figured out. So you enter it here. So the main CIDR block comes to 10.0.0.0/16, and then after that we go with the subnet configuration. So subnet configuration, and then collections dot empty list. So basically this means that we are not going to use any of the abstractions for the subnets are going to be reduced a lot. And then after that we build this. Alright, so now let's build the subnets for availability zone 1. So we had the private subnet A and the public subnet A, right? So let's go ahead and build that out. So private subnet. So now we have to provision the VPC ID. So the VPC in question here, which is demo VPC dot get the VPC ID. For the availability zone, we will be going with AP South 1A for availability zone 1. So the region in which this account has been configured is in AP South 1. For the sake of relevance, I'm going with AP South 1A. So AP South 1A, and then so afterwards we have to define the CIDR block which we have created. So for private subnet A, we went with 10.0.0.0/18. So let me call this private subnet A, and then let's create the public subnet A as well. A, and then public subnet. So public subnet dot builder dot create this public subnet A, and we have to give the VPC ID. The CIDR block for public subnet A, we can enter it right over here. So for public subnet A, we went with 10.0.128.0/19. Alright, so that was the configuration for the availability zone 1, public subnet A and private subnet A. So likewise, let me do the same for availability zone 2. Alright, so I have created the code for availability zone 2, and I have changed the availability zone to AP South 1B, and the CIDR blocks have been added as well. So let's now create the other component which is needed, which is the internet gateway. So we create this internet gateway, and then afterwards we add a route to the route table where it will basically allow outgoing traffic from the public subnet. So let's do just that. Alright, so we have created the internet gateway. but at the moment of creation, this is going to be just floating around. So we need some way to connect that to the VPC, and for that we use a VPC, or rather an IGW attachment. So let's have a look at that. Alright, so let's now define a rule in the root table of the subnets, so that the public subnet is able to route traffic outside into the open web through the internet gateway. So we can do that using Alright, so now the subnets will be able to route any outside traffic to the internet gateway. Alright, so that's about what the code has come to. So of course, if you noticed, we didn't really provision any root tables or perhaps some more abstracted things. So the thing is, this is actually a mix between the higher level construct as well as the lower level construct. So okay, we have all of this math going on, and we were able to figure out the CIDR blocks for each subnet. But will this actually hold up? So let's run this and let's see if our calculations are correct and if the architecture came out the way that we described it to. Alright, so let's get this going on AWS. So if you have worked with the CDK before, and if you have run the bootstrap operation, you don't really need to do this. But just know, if you're running the CDK for the first time, you have to do this command bootstrap. So CDK bootstrap, and then you give your profile. So you actually need to do this only once in your account. Basically what this will do is it will create a kind of toolbox for AWS, so that AWS will be able to kind of use tools like, say, maybe S3 buckets or such, in order to make your deployment possible. So I've already done that before, so I'm not going to do it again. So maybe let's have a look at another command. Let's have a look at CDK synth, and then file. So what CDK synth does is it basically creates the raw cloud formation template. So I'll run this. Oh, looks like there's an error. There's already a construct with name demo VPC IGW in stack 2. Oh yeah, my bad. All this attachment. So I think we'll be good to go now. So let's try that again. Hopefully it works this time. Alright, so it seems like our cloud formation template has been created. Yeah, and if you have a look at what has been created, you have the VPC details, security groups as well, which has been taken care for us under the hood. So that is pretty much what that is. So let me maybe do another command. So that was CDK synth, right? So now let's say if you were to change something in your code, maybe, and let's say you already have this project going on and you have done some kind of change to your code, and you want to see what it is that has been updated within the cloud formation template itself, you can use this command CDK diff. Alright, so let's deploy this using the CDK deploy command, and let's see if we are able to kind of figure out if what we have provisioned has actually been created. So if I were to go CDK deploy, So what happens is I have used the flag all here because in some cases you might be working with multiple stacks. Say you might have, just as an example, a lambda stack or some other kind of compute stack. So sometimes you would want to only deploy certain stacks at a time. So in this case we have only the one stack VPC stack, but regardless I'm just going with the all flag. This might take some time because if you really think about it, AWS has to now provision the components within the VPC itself, like the security group, the route tables, the internet gateway, the subnets which we just spoke about. So it is going to take some time. Alright, so it looks like our VPC has been deployed. So let's go to the GUI and let's have a look at how this has been provisioned and if our math actually worked out. Alright, so we are in the console and it seems like the subnets have been deployed. So we have public subnet A, private subnet A, public subnet B and such alongside the CIDR blocks. Then afterwards we have the route tables and the network connections, which is our internet gateway. So if I were to hover on the internet gateway, you can see that it has been connected to public subnet A and public subnet B, which is exactly what we wanted. The internet gateway of course wasn't connected to our private subnets because of course, well, it's private subnets. They don't really need to access the open internet. So let's maybe look at these subnets and see if our math was correct. So if I were to go into private subnet A, so for private subnet A we have 16,000 available IPv4 addresses and the CIDR block, and it's in the correct availability zone as well. Alright, so that was a private subnet. So let's have a look at the maybe public subnet as well. Let's say public subnet B, and alright, so we have 8,187 addresses for public subnet B. We needed only 5,000. So yes, it looks like our math has of course worked out. Our math has perfectly worked out, and we have provisioned the exact CIDR blocks for each of the subnets as well, and not just in one availability zone but in two as well. And once you're done with all of your deployments, make sure to destroy everything. So you can use the command CDK destroy to kind of tear down everything which has been built. So let's have a look at that. So again, the same thing applies where when we had to deploy, we had to select a stack. When it comes to destroying as well, you are able to destroy either all of your stacks or just certain stacks at a time. So to summarize everything, we looked at how we can provision a VPC, we did the CIDR maths behind it, subnet allocation, and we also had a look into the Java CDK and how to actually program these subnets and kind of define the exact CIDR blocks as well for each subnet, and alongside our route table rules as well. Alright, so thank you for watching. So consider subscribing or liking the channel, or you can share this video as well, and you can also check my other videos as well. Alright, thank you so much for watching.